Hello everyone, welcome to TinkerSpace. Now let's go through the workshop on understanding about Tinker Labs. In this workshop, I will cover on building blocks of a project, various sensors, output devices, controller boards, and 20 different project ideas. Now let's start.
Today we will explore how to design a project or a product using sensors, output devices, controller units, and coding. To make things simple and clear, I will guide you through each step. Let's get started. How to design a product or project. Now let's look at how we can design project by dividing it into three main parts: input, brain or controller, output. Input, where information is collected; brain, which processes the information; output, which performs an action or shows a result. To make things easier to understand, let's compare this to a human system. In a human system, the input is like your eyes, ears, nose, skin, and tongue. They collect information from the environment like light, sound, or even movement. For example, your eyes detect light and your ears pick up sound. The brain is where this information is processed. For instance, your eyes sees a ball coming towards you. Your brain quickly calculates what to do next, whether to catch it, move away, or simply watch. Finally, we have the output, like your hands or voice. Based on the decision made by the brain, your hands might reach out to catch the ball, or you might shout to warn someone about it. Now, in an electronic system, we use the same idea. Sensors act as the input, just like eyes and ears. They collect information from the environment, such as detecting light, sound, or even temperature. The controller acts as the brain, processing that information and deciding what needs to be done. The output devices, like LEDs or motors, perform the action, whether it's turning on a light, moving a robot, or sounding an alarm. So, to simplify, both systems work similarly. Now, let's talk about input modules, which are like the sensors of your electronic project. Let's go through each type of sensor and understand how they work step by step. Light sensor. This sensor detects light. It's like how our eyes adjust to bright sunlight or darkness. The main part of this sensor is the LDR, or light dependent resistor. Its resistance changes depending on how much light falls on it. Less resistance with more light and more resistance in the dark. This allows it to detect the presence or absence of light, distinguish between day and night, and even recognize laser beams or torchlight. Example project ideas are automatic street lights that turn on at night and off during the day, headlight dim-dip systems for vehicles, laser fence for security systems, sun tracking solar panels that move to follow sunlight. Fire sensor. This sensor detects fire or flames. It's similar to how we feel the heat from the fire or sees its light. The sensing element here is an IR photodiode, which is highly sensitive to the infrared radiation emitted by flames. When the sensor detects infrared light, it identifies the presence of fire. Example project ideas are fire alert systems that trigger alarms when a fire is detected, firefighting robots that moves towards and extinguish a fire, automatic fire extinguishers for safety systems. Temperature sensor. This sensor measures temperature. It works like our skin, which senses heat or coldness. The key part of this sensor is the thermistor, which is a resistor that changes its resistance with temperature. As the temperature rises, the resistance decreases, and as it falls, the resistance increases. This helps measure temperature accurately. Example project ideas are temperature controlled fans that adjust their speed based on how hot or cold the room is, engine temperature alert systems in vehicles to prevent overheating. Sound sensor. This sensor picks up sound just like our ears do. The sensing element is a microphone which converts sound waves into electrical signals. It detects the intensity of sound and can even recognize specific sound frequencies. Example project ideas are baby cradles that automatically rock when a baby cries, clap switches that let you turn devices on or off with a clap, IR proximity sensor. This sensor detects nearby objects using infrared light. It has two important parts. The white LED IR transmitter sends out infrared light. The black LED IR receiver detects the infrared light reflected from an object. However, this sensor has a limitation. It cannot detect black objects because they absorb infrared light instead of reflecting it. It works within a range of up to 20 centimeters. Example project ideas are car theft detection systems that sense movement near a vehicle, blind spot alert systems for vehicles, security systems for suitcases or lockers, fast spinning games that use motion detection, rain sensor. This sensor detects water drops or rainfall, much like how we feel raindrops on our skin. It uses conductive lines on the sensor board. When water touches these lines, it completes a circuit and the sensor detects rain. Example project ideas are automatic wipers for vehicles that start as soon as it rains, smart cloth hangers that bring clothes indoors when rain is detected, soil moisture sensor. This sensor measures the water content in soil, just like how farmers check soil for dryness. It also uses conductive lines, which detect the moisture level by measuring electrical conductivity in the soil. When the soil is dry, the resistance is high, and when it's moist, the resistance is low. Example project ideas are plant watering alert systems that notify you when the soil is dry, automatic irrigation systems that water plants only when needed, ultrasonic sensor. This sensor detects objects and measures distance using sound waves. It has two main components. Transmitter sends out ultrasonic sound waves. Receiver captures the reflected waves from objects. By calculating the time taken from the sound to return, the sensor measures the distance to the object. It works up to a range of 400 centimeters. Example project ideas are height measuring caps that tell you how tall someone is, social distance alert systems to ensure people stay a safe distance apart, radar systems to detect objects, automatic lamp light control that turn on when someone is nearby. Now let's talk about the TSOP sensor, which is a special kind of sensor used to receive signals from IR remotes, like your TV remote. For example, when you press a button on your TV remote, it sends an IR signal. The TSOP sensor picks it up and decodes it to tell the system what to do. The TSOP 1838 sensor is the most commonly used version. It is turned to receive IR signals at a specific frequency, usually 38 kHz, so it doesn't get confused by other light sources. Example project ideas are you can use a TSOP sensor to control devices like lights and fans with a TV remote. Build a robot that can be controlled using a TV remote. Create an automatic gate system where you press a button on the remote to open or close the gate. These input modules are essential for making your project interactive and responsive. By selecting the right sensor, you can collect the specific data your project needs to perform its task effectively. Output modules. After we collect information using input modules and process it using a controller, the next step is to show results or perform actions. This is where output modules comes in. Output modules are like the hands, voice, or other parts of our human body that act based on the brain's decisions. Let's go through the different type of output modules, step by step. LEDs. LEDs are simple yet powerful output devices that emits light. Single color LEDs emit one color such as red, green or white. Brightness can be controlled using something called PWM signal, pulse width modulation. How it works? When the current passes through the LED, it lights up. By controlling the current or the PWM signal, you can adjust the brightness. Example project ideas are white LEDs used in lamps, street lights or vehicle headlights. Red or green LEDs used for alert notifications or traffic light systems. RGB LEDs are special because they can emit multiple colors by combining red, green and blue light. How it works? By controlling the intensity of each color, red, green and blue, using PWM signals, you can create almost any color. These are great for making projects more visually appealing or informative. Example project ideas are white light for lamps or headlights, red, green, orange for traffic signals, red, orange, yellow, green for water level indicators in tanks. Buzzer. A buzzer is an output device that produces sound ranging from simple beeps to tones or even music. How it works? It vibrates when electricity passes through it, creating sound. The frequency and duration of the signal control the tone and volume. Example project ideas are alarms or alert systems to warn about hazards, musical gift boxes, safety gadgets or gaming products. DC motor. DC motors are used to create motion, especially in projects requiring speed. Features: high-speed motors, usually around 2000 rpm or rotation per minute, provide low torque, making them ideal for applications like spinning fans or wheels. Example project ideas are mini fans for cooling, dynamo in windmills or turbines to generate electricity, mini robotic vehicles that moves quickly. Gear motor. Gear motors are designed for power and precision rather than speed. Features: low speed motors, typically around 100 rpm, high torque, which allows them to lift or move heavier objects. Example project ideas are robotic projects requiring precise movements, lifting mechanisms like trolleys or conveyor belts, moving heavy weights efficiently. Servo motor. Servo motors are used when accuracy and control are essential. Features: rotates up to 180 degrees with precise control over the angle. Controlled using PPM, pulse position modulation signals. Example project ideas are automatic gate that open and close smoothly, smart straddle that adjusts based on the baby's movements, smart solar panel that tilts to follow the sun, radar system that rotates for scanning, LCD display. LCD displays are used to show text, numbers or simple messages. Features: it can display up to 16 characters per line on 2 lines, hence the name 16 into 2. Supports alphanumeric characters, meaning it can show both letters and numbers. Example projects ideas are game score display for competitive projects, time display like digital clock, counters or step display in automation projects, message boards for showing alerts or instructions. These output models help bring your project to life by showing results or performing actions. When combined with the right input models and a controller, they make your projects interactive, functional, and exciting. By understanding how each output device works, you can pick the one that fits your project's requirements perfectly. Controller boards. Now that we have covered input and output models, let's move to the brain of the system, the controller board. Think of a controller as the brain in a human body. It processes the information collected by input models and decides what actions the output modules like LEDs, motors or buzzers should perform. In TinkerSpace, we have different type of brain boards designed for various age groups and project complexities. Each of these brain boards includes Wi-Fi connectivity, which allows you not only to control your projects wirelessly but also to upload your code without the need of wires. Let's go through each one step by step. Sensor Development Board. This board is designed for beginners, especially younger students, to make learning simple and fun. Features: supports no-code projects, so there's no need for coding knowledge. Includes simple modes for easy operation. Comes with 20 plus ready-to-build projects to get started quickly. Very easy to set up, making it ideal for the age group of 8 to 12 years old. Includes 10 plus input and output units in the box, such as basic sensors and output devices. This board is perfect for younger students or beginners who wants to explore technology without worrying about coding. Tinkerbook Volume 1. This board offers a mix of no-code and coding projects, providing more flexibility and creativity. Features: supports no-code projects for beginners and a special coding system called T-Code for those starting to learn coding. Designed for students aged 8 to 14 years old. Includes 40 plus projects that are easy and fun to build. Comes with auto sensor setups, which means the board recognizes connected sensors automatically. Offers Wi-Fi connectivity, enabling you to control your projects wirelessly and upload your code through the same wireless connection. Comes with 15 input and output units in the box, providing more variety for creative projects. Who should use it? This board is ideal for students who are starting to learn coding and want to explore projects that combine both no-code and basic coding approaches. TinkerSpace Brain Board. This board is designed for advanced projects and students who are comfortable with coding. Features: supports both T-Code and a more advanced coding system called TinkerSpace. Enables unlimited possibilities. Can create as many projects as you can imagine. Includes support for additional features like ultrasonic sensor, IR remotes, LCD display, accelerometers, GPS modules, and more. Allows for mechanical projects such as those using servo motors and DC motors. Offers IoT applications, meaning you can control and monitor your projects online. Comes with Wi-Fi connectivity, allowing you to control your projects and upload code wirelessly. Includes 25 plus input and output units, providing everything you need for complex and advanced projects. This board is perfect for students aged 12 and above who are ready to dive into advanced projects like IoT systems, robotics, and mechanical systems. Tinkerboard. Brain plus robotics. This board is tailored for robotics enthusiasts who want to combine coding with building mechanical systems. Features: supports T-Code and TinkerSpace coding systems. Great for creating unlimited projects, particularly in robotics. Includes additional support for ultrasonic sensor, IR remote, accelerometers, GPS modules, and more. Ideal for building robotics and mini vehicles, making it easy to create and control moving systems. Offers Bluetooth and Wi-Fi connectivity, which allows you to control your robots wirelessly and upload your code without cables. Includes IoT applications, enabling your robots to interact with online systems. Comes with 25 plus input and output units, providing everything you need for advanced robotics projects. This board is the best choice for students interested in robotics and mechanical devices. especially those who wants to integrate wireless control and IoT features. These brain boards give your projects intelligence and make them interactive. With the added benefit of Wi-Fi connectivity, you can control your projects and upload your code wirelessly, making the entire process seamless. Whether you're a beginner or an advanced user, there's a board here to suit your needs. Choose the right brain board and you can create projects that are truly remarkable. Coding platforms. Now that we have talked about input modules, output modules, and the brain boards, let's dive into something really exciting: coding. Coding is how we communicate with the controller boards. It's like writing instructions, or you could think of it as giving step-by-step direction to your project. This is where all the magic happens. Coding is how we communicate with the controller board. It's like writing instructions, or you could think of it as giving step-by-step directions to your project. This is where all the magic happens, because coding decides how your project behaves. At TinkerSpace, we have created a coding platform that's easy to use even if you're completely new to coding. But before I explain our platform, let's take a moment to compare traditional coding platforms with the Tinker coding platforms so you can see the differences. First, conventional coding platforms. With traditional coding, building a project can be challenging, especially if you're just starting out. First of all, you need expert coding skills to understand and write complex programs. The structure of the code can be long and complicated, making it hard to figure out where to start or how to make changes. Then there's hardware setup. You need a lot of wires, connections, and external tools to get everything working. Uploading code is another challenge. You have to use a USB cable and sometimes even a separate programmer to send your code to the controller board. And if you want to add features like wireless control or IoT, it gets even trickier because you need external apps or special configurations. Oh, and don't forget, you will need a laptop or PC for all this coding. This kind of platform is great for experts, but for beginners, it can feel like climbing a mountain. Now, let me tell you about the Tinker coding platform. This platform is designed to make coding simple and fun, especially for students. Even if you have never written a line of code before, you will find this easy to understand. Here's how it's different. First, you don't need to be a coding expert. The platform is made for kids and beginners. So all the coding is designed to be simple and straightforward. The code structure is easy to follow and everything is broken into clear steps that you can understand quickly. The hardware setup is simplified, so you don't have to deal with complicated wiring. One of the best parts, you can upload your code wirelessly through Wi-Fi. That means no cables or extra programmers. Just write your code and send it to your project wirelessly. Adding wireless control or IoT features is super easy because everything is built into the app. And here's the coolest part, you can do all of this directly from your smartphone. You don't even need a laptop or PC to code. Project ideas. Let's explore some amazing project ideas. For each, I will explain how it works and the input, brain, and output devices used. Smart Hat for Blind. This project helps visually impaired individuals detect obstacles around them. In this project, we use the TinkerSpace brain board as the controller. The ultrasonic sensor is used as the input. Its function is to detect obstacles by sending out ultrasonic sound waves and measuring the time it takes for the waves to bounce back. The buzzer is used as the output. Its function is to alert the user with the sound when an obstacle is detected, helping them navigate safely. Smart Dustbin. This project creates an automatic dustbin that opens when someone approaches it. In this project, we used the TinkerSpace brain board as the controller. The IR proximity sensor is used as the input. Its function is to detect the presence of a person in front of it. The servo motor is used as the output. Its function is to open and close the lid of the dustbin automatically. Blind spot alert. This project helps drivers by alerting them when another vehicle is approaching from a blind spot. In this project, we use the TinkerSpace brain board as the controller. The IR proximity sensor is used as the input. Its function is to detect the presence of a vehicle in the blind spot. The red and green LEDs are used as the output. Their function is to provide visual alerts. Red for danger and green for safety. Height measuring tab. This project creates a wearable device that measures a person's height. In this project, we use the TinkerSpace brain board as the controller. The ultrasonic sensor is used as the input. Its function is to measure the distance from the cap to the ground using sound waves. The LCD display is used as the output. Its function is to show the measured height in a clear and readable format. Automatic gate open close. This project automates the opening and closing of a gate when someone approaches. In this project, we use the TinkerSpace brain board as the controller. The IR proximity sensor is used as the input. Its function is to detect the presence of a person or vehicle near the gate. The servo motor is used as the output. Its function is to open and close the gate automatically. Hand gesture controlled door lock. This project creates a door lock that opens or closes based on hand gestures. In this project, we use the TinkerSpace brain board as the controller. Two IR proximity sensors are used as the input. Their function is to detect specific hand gestures such as waving your hand in front of the sensors. The servo motor is used as the output. Its function is to lock or unlock the door based on the detected gestures. Bed height control. This project allows you to adjust the height of the bed using hand gestures. In this project, we use the TinkerSpace brain board as the controller. Two IR proximity sensors are used as the input. Their function is to detect hand movements. One sensor increases the bed height and the other decreases it. The servo motor is used as the output. Its function is to adjust the bed's height based on the detected gestures. Accident avoiding robot. This project creates a robot that can detect and avoid obstacles in its path. In this project, we use the TinkerBot as the controller. Two IR proximity sensors are used as the input. Their function is to detect obstacles in front of the robot. The two gear motors are used as the output. Their function is to move the robot and change its direction to avoid collisions. Edge avoiding robot. This project creates a robot that avoids falling off edges such as stairs or tables. In this project, we use the TinkerBot as the controller. Two IR proximity sensors are used as the input. Their function is to detect the edge by measuring the distance to the ground. The two gear motors are used as the output. Their function is to move the robot away from the edges to keep it safe. Gesture controlled robot. This project creates a robot that can be controlled using hand gestures via smartphone. In this project, we used the TinkerBot as the controller. The smartphone is used as the input. Its function is to send gesture commands to the robot via Bluetooth. The two gear motors are used as the output. Their function is to move the robot forward, backward, left or right based on the gestures. Light following robot. This project creates a robot that moves towards a light source. In this project, we use the TinkerBot as the controller. Two light sensors are used as the input. Their function is to detect the intensity and direction of a light. The two gear motors are used as the output. Their function is to move the robot towards the light source. Line following trolley. This project creates a trolley that follows a designated line on the floor. In this project, we use the TinkerBot as the controller. Two IR proximity sensors are used as the input. Their function is to detect line by sensing the contrast between the line and the floor. The two gear motors are used as the output. Their function is to keep the trolley on the designated path. Object following trolley. This project creates a trolley that follows objects or people. In this project, we use the TinkerBot as the controller. Two IR proximity sensors are used as the input. Their function is to detect the presence and movement of an object or person. The two gear motors are used as the output. Their function is to move the trolley in the same direction as a detected object or person. TV remote control robot. This project creates a robot that can be controlled using a TV remote. In this project, we used the TinkerBot as the controller. The TSOP sensor is used as the input. Its function is to receive signals from the TV remote. The two gear motors are used as the output. Their function is to move the robot based on the remote's commands. Bluetooth controlled robot. This project creates a robot that can be controlled using Bluetooth commands from a smartphone. In this project, we use the TinkerBot as the controller. The smartphone is used as the input. Its function is to send commands to the robot via Bluetooth. The two gear motors are used as the output. Their function is to move the robot forward, backward, left or right based on the commands. Smart Door Lock IoT. This project creates a door lock that can be controlled using a smartphone. In this project, we use the TinkerSpace brainboard as the controller. The smartphone is used as the input. Its function is to send a signal to the controller to lock or unlock the door. The servo motor is used as the output. Its function is to physically lock or unlock the door based on the smartphone's command. Automatic wiper. This project creates a wiper system that activates during rainfall. In this project, we use the TinkerSpace brainboard as the controller. The rain sensor is used as the input. Its function is to detect the water droplets on its surface. The servo motor is used as the output. Its function is to move the wiper blades to clear the water. Medicine serving robot. This project creates a robot designed to deliver medicines to patients. In this project, we use the TinkerBot as the controller. Two IR proximity sensors are used as the input. Their function is to help the robot navigate and detect obstacles. The two gear motors are used as the output. Their function is to move the robot to the patient's location for medicine delivery. Laser fence for home. This project creates a security system that triggers an alarm when a laser beam is interrupted. In this project, we use the TinkerBook Volume 1 as the controller. The light sensor is used as the input. Its function is to detect when the laser beam is blocked. The buzzer is used as the output. Its function is to sound an alarm when the laser beam is interrupted. Car parking alert. This project helps drivers park their cars safely by providing visual alerts. In this project, we use the TinkerBook Volume 1 as the controller. The IR proximity sensor is used as the input. Its function is to detect the distance between the car and an obstacle. The red and green LEDs are used as the output. Their function is to provide visual alerts, red for danger and green for safety. DJ. This project creates a light system that flickers in sync with music beats or vibrations. In this project, we use the TinkerBook Volume 1 as the controller. The sound sensor is used as the input. Its function is to detect the sound waves or vibrations. The red and green LEDs are used as the output. Their function is to flash in rhythm with the music. Creates a fun DJ effect. Hand gesture control lamp. This project creates a lamp that turns on or off based on hand gestures. In this project, we use the TinkerBook Volume 1 as the controller. The IR proximity sensor is used as the input. Its function is to detect specific hand gestures. The LED lamp is used as the output. Its function is to turn on or off based on the detected gestures. Smart Postbox. This project creates a postbox that lights up when a mail is delivered. In this project, we use the TinkerBook Volume 1 as the controller. The IR proximity sensor is used as the input. Its function is to detect when mail is placed inside the box. The red LED is used as the output. Its function is to light up when a new mail is detected. Automatic study lamp control. This project creates a study lamp that turns on automatically when someone approaches. In this project, we used TinkerBook Volume 1 as the controller. The IR proximity sensor is used as the input. Its function is to detect the presence of a person. The LED lamp is used as the output. Its function is to turn on when someone is nearby and turn off when they leave. Torch switch. This project creates a torch that turns on and off by showing light to the sensor. In this project, we use the Tinkerbook Volume 1 as the controller. The light sensor is used as the input. Its function is to detect the light. When you shine a light on the sensor, the lamp turns on. When you shine a light on the sensor again, the lamp turns off, making it a simple and interactive switch. These projects combine sensors, controllers, and output devices in innovative ways to solve real-world problems. Thank you for your time and attention. Stay connected with us for more exciting projects and learning opportunities. See you soon.
Hope you enjoyed this workshop. Now we are ready to start your Tinker quiz. All the best.